Hello everyone, welcome to Script Series. This is our data structure and algorithm series. Today we'll go through the roadmap that we are going to follow throughout the course. The course is divided into 4 sections A, B, C and D. The section A has 3 subtopics. First is basics of data structures and introduction to algorithm. Second is asymptotic notations. Third is recursion and backtracking. Let's go through each subtopic of section A. First is data structures. Data structure is nothing but a way to store and organize data. The data can be of integer type, character type, string type, boolean or any other data type. The word char, int, string, boolean tells us about the data type of the data, that what type of data are we dealing with. These data types are of 2 types, primitive data type and user data type, defined data type. Primitive data types are predefined by the system itself, int, float, char, double and other. User defined data types are defined by the user themselves, like an array. How you declare an array is int, name of the array and size of the array. Then another example is structure. Now how you declare a structure? Like while declaring a node of linked list, how you declare a node of linked list is struct node, and then you describe what all things a node will contain, like integer value and pointer to the next node. This is how a data type is defined by user themselves. Next is algorithms. Algorithm is a well-defined computational procedure to get any task done by the computer. The word well-defined tells about the cost efficientness of any algorithm. So when we are dealing with computers, the cost that we pay for getting things done are, first is time and another is space. Space means memory. How much memory is needed to get a task done. The main property of algorithms is that it takes some input and produces some output. So the next is asymptotic notations. So these are notations that tells how the time complexity or the space complexity of an algorithm grows when we increase the number of input. When the size of input is increased, how the complexity changes. So here are 3 types of notations: big O, theta notation and omega notation. We'll take a deep dive into each one of them. And now the next topic, recursion and backtracking. So recursion is reoccurrence. Okay, when a function calls itself again and again to solve a problem, that is known as recursion. Like factorial of n. To find factorial of n, we multiply n with n minus 1. So n calls itself to solve factorial of n. Last is backtracking. So backtracking is a problem solving technique in which we go through or we explore all the possible ways and paths to get to our desired goal. So the next section, section B, is all about linear data structure. In linear data structure, we'll first see array. Array is for storing similar data type. Like once you stick to one data type, you can't change the data type. If you're storing integers, you have to store integers only. If characters, characters only. And these data types are stored in continuous memory location. Like if you say an array of size 5, then the 5 consecutive blocks will be given to an array. Then we come to 1D, 2D and multi-dimensional array. 1D array is just one array, like continuous, consecutive n blocks. And when we say 2D array, it's kind of a table. Like it has rows of n, columns of n. When we talk about multi-dimensional array or 3D array, it's kind of a grid or cubical structure. Like it will have layer along with its column and rows. Next is linked list. So linked list also stores similar data types, but not in continuous. Like maybe continuous locations may not be continuous, because linked lists have it stores in like a data type along with pointer to its next node. So the address is stored in the node along with the data and address to which the next data is stored. So it may be continuous, it may not be continuous. Next is stack. Now, stack is like normal stack, like a book of stacks. When you say a book of stacks, the book which is kept on the top will be taken or picked up first. Like what we call it in computer science, last in, first out. The last thing that came in got picked up first. And the last is queue. Like any queue, like queue in the store, the first person to come into the queue will be served first. So in computer science, we tell it first come, first serve. We will see all the kind of operations that can be performed on linear data structures, like traversal to go to like every single node or next node. Second is deletion, deleting something from a linked list, array or queue. Then insertion, inserting some data. These all operations will perform on these data structures. Next is section C, which is all about non-linear data structures. So we'll see in non-linear data structures, trees. So what is a tree? Tree is a non-linear data structure that consists of root node, parent node and the leaf or the child node. The root node is the topmost node which is the source, the starting. Then parent node, root node is also a parent node, but all the nodes except the child nodes or the lowest layer are themselves parent nodes. Last lowest level are leaf nodes or child nodes which don't have their child of their own, are child nodes. Priority queue and priority heap are also implemented using tree structure only, and we'll see it deeply in upcoming videos. Last, section D. In section D, we'll see sorting algorithms and searching algorithms. We'll understand how they work, what are the different searching and sorting algorithms, and what are the differences, what are the algorithms, how the time complexity differ in them. Then last, divide and conquer, greedy, dynamic programming, backtracking. These are problem solving techniques that are used to solve programming related problems. So divide and conquer is a methodology which says divide a big problem into small chunks and merge the solution at the last. Greedy, whereas says use the greedy approach, do what gives you benefit instant, like take the shortest path. Now dynamic programming, we decide at each moment like what to do next. Backtracking is about exploring all the possibilities and all the possible ways to get your things solved. Thanks for watching and meet you in the next video.